Solve each radical equation. Our first equation is square root of 4x plus 1 equals 5. Ultimately, in these problems, you want a format where your radical term is on one side of the equation and the other terms, whether it's one or two terms, are on the other. Once you have the radical term isolated, if you have a square root radical, then you square both sides to remove that radical. You have to square both sides to make sure that each side of the equation stays balanced, but squaring will remove a square root radical. The square root and square cancel, leaving you with 4x plus 1 equals 5 squared, which is 25. Subtract 1, you get 24. Divide by 4, and you get 6. Checking your answer, 4 times 6 is 24, plus 1 is 25. Square root of 25 is 5. So that checks out. The next example, we have a cube root radical. It is not isolated yet, so let's add 3 to both sides. That will isolate the radical term. To remove a cube root radical, you cube both sides of the equation. So raising both sides to the third power, your cube root and cube will cancel, leaving 3x plus 1. 3 cubed is 27. Remember that that's 3 3's multiplied together. Subtract 1, you get 26. Divide by 3, x equals 26 over 3. If you substitute back in, 3 times 26 over 3 is 26. Plus 1 is 27. Cube root of 27 is 3. Minus 3 is 0. Sorry, it's taking me a little bit to zoom out. Our next equation, we have, I may just have to zoom and pan. There we go, because I want it to be large enough for you to read. 2x equals square root of negative 5x plus 24 minus 3. To get this square root radical by itself, I'm going to add 3 over. 2x plus 3 equals square root of negative 5x plus 24. To remove a square root radical, you square both sides of the equation. Squaring the square root undoes it, so you wind up with negative 5x plus 24 on the right. Be careful here. That is 2x plus 3's multiplied together. 2x plus 3 times another 2x plus 3. If you FOIL and combine like terms, you will get 4x squared plus 12x plus 9. Because this is a quadratic, we're going to bring everything to one side. Add 5 x's, that gives us 17 x's. Subtract 24, 9 minus 24 is negative 15. This can be factored, but if you're not comfortable factoring one this size, that's okay. I totally get it. You can always fall back on quadratic formula. A is 4, B is 17, C is negative 15. Plug these 3 values into your quadratic formula, you get negative 17 plus or minus the square root of b squared minus 4ac. Remember to solve and simplify the upper left, the denominator, that's 8, and under the radical, your discriminant is 529. Get that discriminant first because you may or may not be able to square root that total. In this problem, we catch a break. Square root of 529 is exactly 23. Using the plus sign, negative 17 plus 23 is 6. Over 8 reduces to 3/4. Using the minus sign, 17 minus 23, that's negative 40, divided by 8 is negative 5. When you check this in the original problem, plug in your 2 answers in for x, one at a time though. So like you would try your negative 5 and you would put it in for both of these x's, make your calculations. If you get the same answer on both sides, great, you get to keep that answer. It turns out that when you substitute in 3/4 in the original problem, you do get matching sides. This answer works. -5 does not lead to equal amounts in the original problem, so that one doesn't work. Only keep the answers that satisfy the original problem. And again, here's the original problem. So you substitute your candidates in. If the left side equals the right side, fantastic. If it doesn't, it's no big deal. You just don't get to claim that answer. Our other example, the last one on this slide, we have x plus 3 to the 2/3 is equal to 25. If you have a rational exponent, rational exponents can be translated to radicals. Whatever your fraction exponent is, the denominator is the root, and the numerator is the power you raise it to. So it's possible you can translate this to cube root of x plus 3 squared. What I did, just to have a direct shot at it, was I took the reciprocal of 2/3, which is 3/2, and I raised both sides of the equation to the 3/2 power. 2/3 times 3/2 makes a 1, so that cleans up and it leaves the x plus 3 without any written exponents. The right side, this is the square root of 25 cubed. Square root of 25 is 5. 3 5s have a product of 125. Solving for x, subtract 3 on both sides and you get 122. If you were to check this answer, 122 plus 3 is 125. Cube root of 125 is 5. Squared is 25. So it definitely does work. Our last example, we have square root of x plus square root of x minus 27 equals 2. This problem has 2 radicals in it, so I'm going to isolate the more complicated one. So let's subtract a square root of x. Once you get your more complicated radical isolated, square both sides to remove your square root. That's going to leave an x minus 27 on the left side. 2 minus square root of x, when it's squared, that's 2 of them, and we have to multiply out. So we have 4 minus 2 square root of x minus 2 square root of x plus square root of x squared. That leaves us with 4. These are like terms. There's a total of -4 square root of x. And then this last term is just x. Square root and square, they battle it out and it makes x. Subtracting an x from both sides of the equation, those cancel. And that leaves us with -27 equals 4 minus 4 square root of x. Subtract 4 from both sides, we have -31 equals -4 square root of x. Divide both sides by -4, and that gives us 31 over 4 equals square root of x. And then to just get x, we're going to square both sides. 31 over 4 squares out to 961 over 16. So that's our candidate. Remember that you don't always get to keep your answers. With square root equations, you have to check them. So in the original problem, I came over here to the side and I substituted in 961 over 16 in place of x. So we have square root of 961 over 16, which is 31 over 34. 961 over 16 minus 27, that's 529 over 16. That has a perfect square root of 23 over 4. Now see, this is all supposed to equal 2 by the end of it, but at this point when we add, we have 54 over the common denominator of 4, which is 27 over 2. That's 13 and a half. That is not 2. Since the number we checked from the end of our problem doesn't work in the original problem, that's the only candidate we had, but because it doesn't check, there's no solution to this equation. And that sometimes is a real heartbreaker because you put all this blood and sweat into working a math problem and the answer you get at the end you don't get to keep.